Okay, we have a problem as humanity. This has been a recurring theme. There's 95% of the ocean that we don't know about. Now, that's a big problem because it's also 2/3 of the planet's surface. And it's deep as well. The land we can map out is only basically two-dimensional, but the sea is three-dimensional. And as you've probably been aware as well, it's a big player in climate change as well. It's both affected by and it affects the climate. So, gathering information about the ocean is essential. The problem is that the current technology is to have a network of oceanographic floats that rise and fall, profiling the temperature, salinity, pH of the ocean. And these are all powered by non-rechargeable lithium batteries. So what happens when these are done? They just sink to the floor of the ocean. Now, it's not actually economical to go and pick them up, because though they're 20k per float, the cost to go and get each one is hundreds of thousands. So they're just trash on the bottom of the ocean. So, okay, we can measure the ocean, but we have to leave some trash there while we do it. So, what if you can have a rechargeable battery on a float that wouldn't need to be trash? Okay, you could do solar. You need to come to the surface, open some solar panels, wait for the sun to come out, and it might never come out. You could do wind. You could come to the surface, you could have a little turbine generator and wait for the wind to start, and it might never start. You see a theme here. You could do wave power, but what if there's no waves? You've got some problems. But as you go up and down the ocean, there's a change in temperature. The bottom of the ocean is pretty repeatedly 4 degrees C. The top of the ocean, in most of the planet, is pretty repeatedly about 20 degrees C. So what if you can make use of that temperature difference? There are existing technologies that make use of temperature differences all the time. In a nuclear power plant, you use the nuclear energy to heat water, and you extract energy from the heated water with a steam turbine. But that's what's called high-quality power. That's about 100 degrees C for temperature difference, which is a lot. What we're talking about here is maybe 15 degrees C for temperature difference. Low-quality energy. But what we do is we use a material that changes phase in the middle of that temperature gradient. So this is pentadecane. It's paraffin. It's a little like candle wax or diesel. And at room temperature, at the top of the ocean, it's liquid. As my beautiful assistant here is showing you, this is a test tube of pentadecane. It's been in ice for about 5 minutes to freeze. And you can see it's kind of waxy, crystalline, solid. Now, like most substances, it changes volume as it changes phase from solid to liquid. You may know that your pipe, actually here, probably not, you may have heard that elsewhere in the country, pipes crack and freeze over winter. Here, not a problem. So that's the water expanding as it turns to solid, and you can't hold it back. That water is going to expand. Even if there's a pipe around it, it's going to burst that pipe if it has to. It's the same deal with this stuff. As it melts, it needs to expand. And you can try and contain it, but it will push against up to 20,000 pounds per square inch of pressure if you try and contain it. So that's what we do. We contain it with about 3,000 pounds of pressure, and as it expands and melts, it pushes a spring, a gas spring. Then once it's done, we release that gas spring, and we drive a motor with it. So this is one of our tubes. This is a PCM tube. That's going to hit the microphone. 1 minute, okay, good. Great. So this has been fun, guys. 1 minute left. So this is a PCM tube. We have oil in here, paraffin in here. This goes in there. Paraffin expands and melts, expands, drives the oil out of here. This drives a generator which recharges the battery. And then we've got enough energy to do the whole thing again. We power the float that's attached to us. We go up and down forever instead of just 200 times the standard floats do. So usually 200 times your float is trash, and you get about once every 10 days you get a dive. With our system you can go 4 times a day. You can get 40 times as many dives in the same space of time. You can get 40 times as many data points. You can reduce the cost per data point by a factor of 40. You can use 40 times as much energy if you want to go all the way to the bottom of the ocean. So the opportunities are limitless. And we completed a prototype from JPL, the license that went around Hawaii for 18 months. And we have multiple opportunities in different scalabilities. It's portable, it's clean, and we're planning to deploy to the ocean soon with our commercial prototype. We can also target the Arctic and land-based desert applications. All you need is a temperature difference. If that's physical space that's different, or just different over time with the day and night differences in the desert. That's not me. So we'll stop there. Thank you.
Thank you so much.